Okay, let's begin part 2. And then at the end of part 1, I told you what this line does, application.doEvents. It allows you to input commands while in a loop. In this case, our game running loop, or the loop that's happening in our game. So now that the application is responsive, we need to think about what happens in a game, or what we need to remember when a game is happening. And there are 6 big things usually. So let's go ahead and write a list first. The first usually is the program needs to be able to check for user input. Because you as the user are typing in commands and the program needs to be aware of what you're typing in so it knows what to do. A game's pretty boring if you cannot type in commands and you're just sitting there for an hour. So checking for user input. The second thing we usually want to do is we want to run the AI, or the artificial intelligence. Chances are there's other things on your screen happening or people moving around that you don't have control over, and the program needs to keep track of them as well, or else the game is kind of boring. Or maybe you don't have AI. But usually most games do have some kind of person to shoot back at you or, challenge you in some way. Third thing you want to keep aware of is you want to update object data. This can include things like the position of NPCs or non-playing characters, the status effects on your party. So are any of you poisoned? Are any of you stunned? Things like that. And who knows? Maybe the number of items you're holding. So like inventory or something, because you might have an inventory system. But there are a lot of other things that can happen. So I'm just going to etc. And you got to keep track of all of those as well. And the great thing about writing it in a list like this is that we're going to break it down. We're not going to just, if you think about the entire game in its entirety at the beginning, it's a lot to take in. But if you break it down into different categories and then work on one category at a time, it becomes a lot more manageable. The next thing we need to be able to check, for triggers and conditions. So maybe there's something happening in your level like an ambush. An ambush would be considered a trigger because enemies are popping out of somewhere and it's triggering something. A condition could be you've met the goals of a challenge or you've met the goals of a mission. So since you've met all the conditions of that mission, something happens, something triggers, and you get something or you move on to the next mission, so on and so forth. The fifth thing you want to keep track of, or you want to make sure you're doing, is you want to be drawing the graphics onto the screen. And that's probably going to be one of the first things we do, because if you can't see the game, you can't play the game. So we need to make sure that the graphics are constantly representing what is happening on the screen. And then the final thing, which isn't that important, but a lot of people have it, you want to be able to play sound effects and music. So if you're in a zone of some sort, it's playing a song, and this isn't really hard to do. It's not paramount to the code itself, so it's usually way down in the production of things. But those are everything we need. And this list also comes from this person's channel. Like I mentioned in the first video, this code is based off of his code, and everything that you see here was designed and developed by this person and his YouTube channel. So I can't take credit for this. Eventually I will make my own game, but since I'm still a novice at Game Design. I'm giving, or this is his work, so all credit goes to him. Yes, or his YouTube channel. So before we start making the graphics, let's make sure that our game is, make sure that our game, let me just put a comment here, is running and that we know it's running. So let's develop a counter for our frames per second. And this is going to utilize the variables we created up here for our frames per second variables, the int seconds, which is picking up times of day, the int frame rate, and the int max frame rate. And let's just put in the main code. Or no, let's just make a procedure. It's not that hard to do. So let's call this frames per second. And after this end sub, let's create a procedure called frames per second. And then we'll need the following. If, oops, what am I forgetting? Oh, and I don't know why I didn't write the end sub. Let's just put an end sub there. Oh, because I forgot to put sub here. Private sub. There we go. Okay, so inside this, and it's the same for all programs, or very similar, if int seconds, is equal to time of day dot second and is running, if bool is running is equal to true, then let's add 1 to int frame rate. So int frame rate plus equals 1. Else max frame rate is equal to int frame rate, and then int frame rate is equal to 0. And I'm going to explain all this in a second. And what are we forgetting? Int seconds is equal to time of day dot second. If I can spell. Okay. So that's it. Okay. So let me explain what I did here. In our main program, we have a procedure called frames per second. Whenever it hits this line, frames per second, it goes over to the procedure called frames per second. If int seconds is equal to time of day dot second, which is that current second, let's say we ran this program and it was at the 40th second, so the second was 40. It would have automatically at the start of our program been stored in here. Would have been equal to 40. So while in seconds, while 40 is equal to 40, because right now that second is still on 40. Okay? And bool is running is equal to true, then let's just add 1 to our frame rate. So our frame rate is starting at 0. And it's going to add 1, and then it's going to go back, it's going to run this while loop again, it's going to enter here again, and if this is still true, it's going to add 1 again to the frame rate. And this is going to keep happening back and forth, back and forth. But eventually, the second is going to change from 40 to 41. So now in second is 40, but the time of day dot second is 41. So this is no longer true, because 40 is not equal to 41. So then it's going to go into the else statement, which is it's going to take our frame rate, which it has been adding over and over again over here, and it's going to store that number into the int max frame rate. It's going to store it inside of the int max frame rate. And now that it's been stored, we're going to print it out to the screen eventually, but we need to set the frame rate back to 0, because now we're at second number 41. So now it has to happen again, and it's need a loop, 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 loop until this is 42, and then do the same things again. So every second this starts up again, and we need to set this back to 0 so that our frame rate is actually counting the amount of frames happening per second. And then we also need to change int seconds to int time of day. So the second this becomes 41 or 42 or whatever, we need to update in seconds to 41 or 42 so that this is true for the remainder of that second that is happening. So take a second or take a minute to look at this code over here. Make sure you can kind of see why it's running or what it's doing. Right now it's not printing out to our screen just yet, so it's not going to do anything. But be sure you understand what is happening in these lines. And if you don't, raise your hand, ask me, and I will tell you, but don't move on from this point if you do not understand what is happening here. Okay, so now that we have a procedure that's going to tell us our frames per second, let's work on number 5. Let's draw some graphics onto the screen. Now, if you're expecting to draw Minecraft for your startup project, I have bad news for you. You're probably not going to get there for your first project, especially not in Visual Basic. We're going to stick with 2D for now, and if any of you figure out how to do 3D, definitely let me know, because I'm sure there is a way. But let's go ahead and create a new private sub, and let's call this Draw Graphics, because that's what we're doing. And we're going to use our graphics variables for this, which luckily we initialized as global variables. And we need to do a few things. First of all, we're going to draw like a bunch of rectangles here onto our screen. So if you can kind of think of like a chessboard or something, we're going to have the program draw it. And we're going to, let's use some for loops for this. So let's utilize for loops. And I'm going to explain this in a second. Let me just code it on the screen first. For x is equal to x is equal to 0 to 19. And I believe okay, change it to this. This is going to work a little bit better. For int x equal to 0 to 19. Let me say this loop is going to draw tiles on the screen. For int x is equal to that. And let's make another loop inside the loop. So this is a nested for loop for int y equal to 0 to, I believe the number is 14. And I'll explain all this in a second, so if you're a little confused, no worries. R is equal to, and if you remember, R was our rectangle. Over here, we initialized R as a rectangle up here. R is equal to a new rectangle, because we haven't given it a value yet. And then int x times 32, comma, int y times 32, comma, 32, comma, 32. Okay, and then g.fill rectangle, comma, brushes, dot, let's use burly wood, comma, R, and G dot draw. Okay, welcome to the video game G dot draw rectangle, comma, pens dot black, comma, R. Okay, so what's happening right now is that right now we have a screen that is 750 by 550 pixels. And we're using that new rectangle command to draw rectangles onto the screen. So right now at int x, it starts at 0. So this is going to be 0, and it's going to draw a rectangle of size 32 by 32 onto the screen. And then it's going to move 32 pixels over to the next one. And at every 32 pixels, it's going to fill in a rectangle, and it's going to fill in a rectangle. So it's going to like draw in a colored rectangle, and it's going to make it the color of burly wood. So we have different colors we can use, like I could say red, but the color they used was burly wood, so I'm just going to stick with that. But there are a lot of colors that you can have it paint. And it's going to paint that, and it's going to use R because R is the rectangle information that it needs. Then after it's drawn or colored in a rectangle, it's going to put an outline on that rectangle. So it's going to draw a rectangle, and it's going to draw it using the pen command, and it's going to be colored black, and it's also using the same information from the rectangle that we typed in before. So let's go ahead and first off, let's see what this does. Head over to your main program loop, and inside of Draw Graphics, let's put in the name of this, which was Draw Graphics. So Draw Graphics, and I'm going to give this a run. And if you look at your screen right now, you'll notice that it has everything on, or this interface on your screen. You'll notice some flickering there. That's because we haven't set up our back buffer yet. So when I was talking about the flickering that was happening, you can kind of see it if you look close enough. It might be a little hard to see in this video. But this was generated from this loop over here. It filled out rectangles, and then it drew out rectangles. If you want to stop this and change this to red, run it again, you'll notice that you change it, and it changes the color of that. If you want to have rectangles that are smaller or larger, you can change the pixels on them. So let's say instead of happening every 32 pixels we draw a rectangle, let's say every 16 pixels we drew a rectangle. I'm going to change this to 16 by 16 pixels. And actually, let's have it stay at 32 pixels distance-wise. So if you run it, you look what you created. You created small boxes, and they're all colored, but they're 32 pixels apart, but the rectangles themselves are 16 by 16. And the black outlines are 16 by 16. And it's also important to remember that the order of this matters. If you drew out the outlines first and then filled them red, you would actually override the color black. So let me show you. I'm going to drop this line. It's not letting me. Let me just copy, paste it. Oh, it's still running. That's why. Okay. If I drew out the outline of the rectangles first and then colored the entire rectangle red, and you run the program, you'll notice that there is no black outline. Because the second you put the black outline, then you automatically fill in the red rectangle with red, and now you can't see anything. Okay. So what I want you to do is I want you to practice with this. I want you to figure out exactly what is going on here before you move on to the next video. And your assignment, since this is the end of the second video, I want you to show me something cool with this command. So do something awesome and show it to me, and that will be your proof that you understand what is going on up to this point. Okay, I'll see you in the next video.